All right, first thing today is we are going to do what's called the traveling washer activity or the traveling circle activity. And on the very back of your paper is a blank page. And so you're going to start down in the bottom left-hand corner. And you're going to draw a little circle. And it tells you that that circle is moving to the north for 3 centimeters. So you're just going to draw a little arrow. You're going to draw a vector. Okay. So get a ruler, draw a north arrow 3 centimeters. And then the next thing it says is it's going to go to the east at 7 centimeters. So you're going to draw a vector going to the right, which is east, for 7 centimeters. And then you're just going to follow along, and you're going to draw all of the vectors that it lists, and you're going to end up with something like this. Okay. So what we're looking at is we're looking at the difference between distance traveled and displacement. So if we want to know the total distance that our circle travels, we're just going to add up all of those vectors, say just the distance of all of those. So we do that and we end up with 34 centimeters. So going from here to here to here to here to here, following this path, we're going to go 34 centimeters. And that's your total distance traveled. That's what that means. Now displacement is a little bit different. Displacement is how far away are you from where you started. So it doesn't matter what path you take, you're just looking at your final and ending position. So if we draw a line from our start to our end, we are actually drawing a vector. This is our displacement vector. Okay, displacement is a vector quantity. And if we measure that, we're going to find that we are actually 14 centimeters away from where we started. A lot of times you'll hear this called something like as the crow flies. Right? So in order to get to somebody's house in the middle of nowhere, you have to take the roads. You have to follow that path. But a bird can fly from wherever you are straight across. So that's your displacement. It's a straight line distance between where you start and where you end. Now it is a vector, so we do need to include direction. And so in this case, we're moving partway to the north, partway to the east. So we would say that our displacement is 14 centimeters northeast. So what we're looking at is kinematics, right? We're looking at the study of motion. Okay, that's what kinematics means. And when we talk about motion, we're talking about an object's change in position relative to some reference point. Now we've been talking about a reference point, but we haven't actually written it down and defined it yet. But a reference point is just the point from which you take your measurements. And that is up to you. You can make your reference point whatever you want. It's something that can change, but you get to define it. So let's look at distance. Distance is abbreviated D, and it's how far an object travels. So that total distance that we had our little circle going, that's going to be our distance traveled. This is a scalar quantity. Scalar quantities do not depend on direction. So if we've got our ant standing there on that 0 line, and he moves over to the 3 centimeter line, what is the distance that he travels? Well, it's a pretty straightforward one. He travels 3 centimeters. Displacement is the difference between an object's final position and its starting position, and it is a vector. So when we describe the displacement of our ant, he's going to go from 0 centimeters to 3 centimeters, but we have to include the direction. So the displacement of the ant is going to be positive 3 centimeters because he moved in the positive direction. So that's really the distance, So that's really the difference between distance and displacement. The ant walked 3 centimeters. That's a distance. The ant walked 3 centimeters to the east. That's going to be displacement. Or the ant walked positive 3 centimeters. That's going to be displacement. And there he goes. All right, now, what if our ant starts over here on the 3 centimeter mark? What is the distance that he travels if he goes back to the 0 point? It's still 3 centimeters. His direction does not change the answer. He still travels the same distance because it's a scalar quantity. We don't care about direction. Now, displacement is a little bit different. The magnitude of our displacement is the same. He still travels 3 centimeters, but he's going in the opposite direction. So our displacement is going to be negative 3 centimeters. So again, here's that difference. Our ant is walking 3 centimeters. But when we talk about displacement, we have to include that he's going a negative 3 centimeters, or 3 centimeters to the west. So what if we make it a little more complicated? We've got our ant, and he's going to travel to the 5 centimeter mark, turn around, and come back to the 3 centimeter mark. What is the total distance that he walks? Well, he went 5 centimeters, and then he came back 2. So the total distance that he traveled was 7 centimeters. Now, what about his displacement? He is going to travel 5 centimeters in the positive direction. He's going to turn around and travel 2 centimeters in the negative direction. Okay, so where is the ant compared to where he started? These are vectors, and we're going to add these vectors together. So he went a positive 5 centimeters as his first displacement. His second displacement was a negative 2 centimeters. Now remember from forces, when we have vectors that are working together or working in the same direction, we add them up. When we have vectors that are working against each other or in opposite directions, we subtract them. So if we take that positive 5 centimeters and that negative 2 centimeters, we're going to end up with a positive 3 centimeters as our displacement. So our ant ends up, even though he travels 7 total centimeters, he's going to end up 3 centimeters on the positive side of where he started. So this is where that distance and that displacement kind of really starts to make a difference. Right? Up until now, we've all been in straight lines and everything has been equal. But now, the distance that we traveled is not the same as the displacement. We traveled 7 centimeters, but we only ended up 3 centimeters to the east of where we started. So here's an interesting one. We've got an athlete going around a track that is 400 meters long, and he's going to do that 3 times before he stops. What is the athlete's distance and displacement? So if our track is 400 meters long, and he does that 3 times, our distance is going to be 1,200 meters. He ran 1,200 meters. But what about our displacement? Stop and think about this for a minute. Where did he end up compared to where he started? He ended up in the same place. So his displacement is going to be 0 because he's 0 meters away from where he started. So even though he ran 1,200 meters, long run, even though he ran 1,200 meters, he still ended up in the same place that he started. So his total displacement is 0. So we're going to walk 5 meters east and then 3 meters west. What is the total distance that our student travels? Okay, so again, total distance, we went 5 meters and then we went 3. So our total distance is going to be 8 meters. What is our displacement? It's going to help to draw these out. Draw that vector. We have 5 meters in the positive direction, and then we have 3 meters in the negative direction. They're moving in opposite directions, so we're going to subtract them. And so we're going to end up with a displacement of positive 2 meters. Now what if we have a polar bear? We've got a polar bear wandering south, 275 meters. And he turns around and meanders 427 meters north. What is the total distance that he travels? So we're going to add those up. 275 plus 427 meters is going to be 702 meters. Now what about his displacement? He's traveling to the south, negative 275 meters. Now typically we say south is negative. We could totally make this positive. That would be fine. That's just going to change our signs. But then he turns around and he goes 427 meters in the other direction. So he actually passes where he started. Now again, these are going in opposite directions. So we're essentially going to subtract them. We have 427 meters minus 275 meters. That's going to give us his displacement of 152 meters on the positive side of where he started.